Hi everyone, and welcome to another session of 90 Days of DevOps. My name is Pepe, and I work at Grafana on the Basic team. In this video, I really hope you learn something new. There are two main topics in our agenda. First, I'm going to give an overview about what is performance testing, their goals, what are the different types of tests, and also the different existing tools. Then, it's going to be demo time. I'm going to run a quick picture our demo project. There are quite a few basic tests showing different basic functionality. The good thing about this project is that you could also run on your own these examples and many more. I know your time is important. Let's get started. The goal of performance testing is to verify the reliability of the system that we are testing. And normally we look at three different aspects. First, the latency or response time, how fast our system responds. Then also if our system is responding with error or some internal errors are happening. The functional aspects, too. There are going to be some tests that are integration tests between different components or end-to-end tests for common user flow. And we may not have tests those things under load. The key aspect is to have in mind that our system will not perform the same with 10 users or 10,000 users. This is why performance testing and load testing are very related. Load tests are just performance tests using load. There are a few common types of load tests. They have different goals and also different test options. The two main test options are the test duration, for how long our test will run, and the test load, how much traffic our test will generate. We could see the different tests depending on these two options. We have the average load test. It's a test that is going to simulate our average traffic for some specific test case. Stress test will simulate a moment of high traffic. And similarly, we have a spike test. It will simulate a moment of a peak of traffic. Maybe people connect on a moment of the day, and then we come from very low to very high very quickly. Then we have a smoke test. It's a test with minimal load, minimal duration. We want to verify that our system behaves well with this minimal load and also that our script works. It could have many different goals. Then we have soak test too. It's going to be a test for very long period, hours, 2 hours, 4 hours. We want to see if our system gets saturated after being used for some hours. And then a breakpoint test. Similarly, we are going to try to find the limit of our system by increasing the load continuously. When our system gets overloaded, we will stop the test. We have considered load tests to be just performance tests using concurrent load. And you may wonder, what are the performance tests using a single user or single thread? It's going to be a mix of different tests using different tools. Like, for example, profiling tools. We could run a test and look at our profiling tools to see the execution time of a particular function. Or look at the traces on our observability solution to see what is the time that a service spent serving a particular request. We have also browser performance tests. We focus on the front end to optimize assets or measuring, for example, the rendering time. In that case, we don't need also to inject load in the backend. Or synthetic testing or synthetic monitoring. Normally it's testing or checking very frequently our production system to see the availability. At the end, any type of test that are going to check the performance could be considered a performance test. I'm going to focus on load testing because it's the most common use case for performance testing. I wanted to show what are the different options or tools that we have available. I found this awesome list here, Load Testing Toolkit. It's created by Alexander Belli, and it gives the collection of the different open source tools. As you can see, there is many different options. This is why it's good also to classify them depending on how we could use them. First type of tool are benchmarking tool. We pass an endpoint or a list of endpoints and the test option. WK is one of those tools, and most of the tools works very similar. You can see here we pass the endpoint, the test option, and that's it. At the end, it will print the results of the test at the terminal. Then we have similar, but for different protocol, like for gRPC, MKey, Kafka. There is a few of them on the previous list. More powerful tools are the ones who allow multiple protocols or create a test with different steps. GMeter is probably the most popular one. It was created, I think, more than 20 years ago, and it has a big community. In GMeter, you can create your test using the graphical interface. There is other option, but this is the most common one. You create the different steps, and you could just change any setting with the UI. On the other side, we have what we call code-based testing tool or scriptable tools. There is a few of them, like Locus, Gatling, and Casey could be the most popular one. Each one using a different programming language. And the scripting language gives you more flexibility on the way that you could create your test. And last, I want also to mention those who are accepting a YAML file, like Artillery. We could see here an example. You could also use different protocol, defining different steps, but I would say that it does not have the flexibility of a scripting language. And now, let's get started with Casey and our demo. Here we have two URLs, the Casey documentation and the URL of our demo project, QuickPizza. Let's start with the documentation. The first page is an overview about what is Casey, key feature, use cases, where manifesto and Casey is not. I want you to click on Get Started, Installation, and from there, please choose the instruction of your operating system or package manager. I have already installed K6 here, and as you can see, I do K6 version, and I have already installed version 0.46. If I do K6 help, I get the different command. Before we go into our demo, I want to give an overview about the different way of running K6. Here on running K6, at the bottom, we have what we call the execution modes of K6. K6 supports 3 execution modes: local, distributed, and in the cloud. It is our intention that independently of how you execute K6, you can run your same test on any mode without any change. That's what we say here. You can run the same test in different modes with minimal change. In your local mode, you are going to run your test wherever you have installed K6. But you could run the same test on the distributed mode with a Kubernetes cluster. In that case, you distribute the load of the test across different Kubernetes pods. And then we have also our cloud service, our commercial service. This is mostly used for teams who want to scale their testing or want to do continuous performance testing. Let's see now our QuickPizza app. We click with QuickPizza. This is a very simple app. There is different way of running this project, like for example with different Docker Compose setup. We are going to choose the local one. QuickPizza, we will see now, is a simple app to order pizza recommendations. And then we have quite a few tests on this project to run K6. Let me pick the instruction here, this one, Docker Compose local app. And we are gonna run that. My machine, I have already run those project. Let me see the file here. In this Docker Compose setup, we have QuickPizza running and also a Grafana instance that we are gonna use to visualize our test results. There is also other projects that are instrumenting our application, but we are not gonna see that now. So now that it's running, we are gonna go to localhost and we are gonna see QuickPizza. It's a very simple app. We can order pizza, this is gonna be a post. Give me one pizza and we are gonna get a pizza recommendation. There is also an advanced mode, and here the importance of this project are the different basic examples that we have here. So there is different examples here for different features. Foundation, we have also for the browser project, and also more advanced use case. We are going to be focused mainly on the foundation folder, and we are going to be running different tests and discussing different basic features. I will start running the first test on the foundation folder. We go to K6 foundations, and there is a number 1 basic. This is a basic text. We import the HTTP module to do different HTTP requests and some other basic API that we will use. We could pass an environment variable based URL to say the URL of the quick pizza app. By default, it goes to our localhost environment. And here, using option is how we set up the different load options and many other more. We are telling KSIG to run 5 virtual users during 10 seconds. And during this 10 seconds, KSIG will be executing the default function that we define here. This function, the only thing that it does is to create a post request for pizza, and it's asking for some pizza recommendation. Then we assert that the status of the response is 200, and we're gonna be logging the name and the ingredients that we get from the server. Then we also sleep during 1 second. Let's run this test. Here, basic run foundations number 1, basic. Now our test is being executed and is logging all these pizza that we are getting from the server. And at the end of the test, KSIG output on the terminal some of the test result metrics. We could see here the number of views, the minimum and maximum were 5, and also here the number of iterations. Iteration is an important concept in KSIG, and iteration is the execution of the default function. In KSIG, we could model the load in terms of duration, run during 10 seconds, or also iteration. Let's change the previous example. We could say KSIG run 20 iterations with these 5 virtual users. And now we run the same test. You could see here the number of shared iterations between all the views, and we have now run 20 iterations. Those are the main concepts to define the load and the function that we are going to be executing. We have seen view and durations and iterations. And KSIG at the end, what it's going to do is to schedule a number of views that they are going to be continuously executing our scenario. It's going to work like that. X number of views continuously being executed the scenario. This is what a load test is. But there is also different way to set the load. There is many options. Other one is a stage. Stage, we define different stages. We remember this ramping that we see at the beginning. We were saying KSIG go from X number of virtual users to another number in a period. The same we do here. So in 5 seconds, we go from 0 to 5 virtual users. Then we will be, during 10 seconds, running 5 virtual users, and we end with going to 0 virtual users in 5 seconds. Let's run the same test. Okay, not the same test. This new test, we do basic run, foundations, stages. Now we see here we are running the test for 20 seconds. And in this way, we can model the load as we want. Let's finish. Test. So we have run this time 30 iterations. We could be doing anything that we want here. We could add 20 seconds, 50, or yes, even 1 minute. We recommend not to do too much ramping, because at the end what you want is to start getting into the load that you want and to be continuously testing this load to see how your system performs, and then maybe ramping down. But there is also other ways to set up the load in K6, like requests per second. In K6, you could use the constant arrival rate scenario. In this case, you set the number of iterations that they are going to run over a period of time, number of iterations per second. K6 does not have the option to set specifically the number of requests per second. The reason is that in your function, you could be executing one or multiple requests. Here we have one, but it could be many more, and K6 doesn't know in advance. But you could schedule a number of iterations per second with this scenario. Those are the different options: the duration of the test, the rate of iteration per time unit, in this case 1 second. Let's see one example, just copying these settings into our previous test. Oh, this is the number of the scenario. Let's change the name, scenario 1, and instead of 30 seconds, it will run for 10 seconds to a rate of 30 iterations per second. We also need to remove the sleep time, because now we don't want K6 to wait after the end of the function. And let's now run the test. K6 run foundations stages. We can see here is executing 30 iterations per second. And now at the end of the test, we are going to see the number of requests per second. We have here iteration 31, a rate of almost 30 iterations per second. And because we are running one request, in each iteration, we have the same number of requests per iteration here. This is the HTTP reqs metric, number of requests. It's going to look something like that. So the number of iterations per second, 30. We have one request per iteration. Then we will achieve the 30 requests per second. You could do the same just to achieve the number of requests per second that you want. And now let's go over the documentation of K6 metrics to understand better about test results. Metrics are the information that K6 collects during the test. Some information could be about the test execution, like information of virtual user iteration, or data when interacting with your system, like the latency or response time. There are 4 types of metrics: counter, gauges, rates, and trends. We could see them on our previous results. We saw that on our previous example, like for example, check. Check is a rate metric. Give me a percent, like 100% of checks were okay. Then data received, data sent are counter metric. Give me the number. Then for the information about our HTTP request are rate metric. The information are about percentiles. It's going to collect all the information, all the data point, and going to give me the percentile, the statistic. And other counter metric like HTTP reqs, they give me also the rate here on the terminal. Those are the metrics that K6 collects by default. We have here built-in metric, but there is also other metric that you could create on your test to measure things that K6 does not collect. Let's see first the built-in metric to get familiar with this page. Here we list all the different metrics, like current of active virtual user, the type, information about iteration. The one that normally are more important, and we have seen a few of them like HTTP rect, the request rate, the view, also the number of active virtual users, or the request duration, the response time spent on the request, excluding the connection time. There is also other metric, but those depend if you are using some module or not. For example, browser metric, if you use the browser module, or WebSocket metric, gRPC metrics. Let's see now about custom metric. We have custom metric. Those are the ones that we could define. By default, you're going to import the module with the type of metric, counter, and then you are going to instantiate in your test. Let's see one example that we have in Quick Pizza. Is our sample number 4. And we are here just importing the module first. We want to create two types of metric, one trend and one counter. And first we instantiate the metric. We are going to collect the number of pizzas that are returned and also the number of ingredients for each pizza. One is going to be tech trend and the other counter. In our scenario, we are just adding on the counter one pizza more, and then on the ingredients metric, we add the number of ingredients of the pizza that we got from the server. Let's run this test now. This is foundation number 4. Gonna work like before, but now we are gonna have this information about this custom metric on the terminal. And here we are. We have Quick Pizza ingredients and Quick Pizza number of pizza. We say ingredient was a trend metric, and then we got the statistics. The minimum number of ingredients was 5, the maximum was 8. And for the counter, we got the sum of all, the 38, and also the rate. Let's continue to know more about the different basic options. We have already seen that when running our KSIG test locally, KSIG prints the results on the terminal. This is what we call the end of the test result. Let's see here on the documentation. There are 3 more options: CSV file, JSON, and the custom summary. Basically, with the custom summary, you can customize the end of the test summary. We are going to see one simple example. Here, we have our handless summary function. We need to write the same function that receives the aggregated results here on this data variable. Now in our function, we could do whatever we want with this data. We could send outside, we could save in a file. In this example, we are just formatting the results on JSON and saving on the summary file. Also, we are presenting the data on a different way here. But let's see just the JSON file so that you see how the format looks like. In this JSON file, we have information about the KSIG results. Like groups is an API, check is another API, and the different metrics that we have seen before. But it's important to know that this is just aggregated information. And sometimes with aggregated information, it's very difficult to know what is happening in your system. Because when we run a test, maybe something happened at one particular moment. And this is the moment that we are getting a slow request or we are getting some error. And you may want to know when is that particular moment. Whenever we got this aggregated information, we are not going to know. We are going to know maybe we have 20% of the request have failed, but it had been at the beginning, at the end, it had been continuous. It's hard to know. This is why also KSIG provide options to send the raw data, the different data points that it collects in real time to any backend. Gonna work like that. We have these 2 options, and by using the output CLI flag, we could tell KSIG to send the results to any backend. Here we have a few options. The important thing to know is that you could create any output that you need. There is a few of them for the community, but you could build your own. If we go back to the documentation, we have here extensions, create an extension, and here on output extension, it gives us the instruction on how to build our own output. As I say, there is many different ones. Let's see here, result output, terminal, some CloudWatch, Kafka, Datadog, Dynatrace, Elasticsearch, Fana. If really, we are going to see the Prometheus remote write. If we remember, with our Docker Compose setup, we were also running a Prometheus instance and a Grafana instance. The only thing that we need to do now, because we are running our Prometheus instance on the default URL, we are going to just pass to KSIG this output parameter to tell KSIG whenever you run the test, stream the results in real time to the Prometheus instance. Let's run the previous example. Now KSIG is running and is sending, as he say here, output Prometheus, yes, to the instance that we are running here. But we have also our Grafana instance, and we have already installed one dashboard to visualize the results from Prometheus. And here we are. Now we can see how this data has been sent to Prometheus, and from Grafana we are querying this data. We have designed this dashboard, which is public, and it visualizes the main KSIG metric. We could see here a transfer rate, iteration, latency, information about the different checks. At the end, you could customize this dashboard or also build your own one. As I am running out of time, let's go quickly through our last KSIG feature, assertions. There are two ways of defining assertion in KSIG, using the checks API or the thresholds API. The difference is that also about the syntax that we use, but the big difference is check that don't make our test fail. Even we have a check failure, our test will not fail. For that, we use threshold to define the pass-fail criteria of our test. Let's see the checks example. We already have a check before here on our metric example. I have added now one more. We check that the pizza have more than 6 ingredients. Check. I'm gonna just verify a Boolean condition, and we could have as many checks as we want for one request or for any other request or for any other object that we want to validate any condition. Let's run this test, and we are going to see how at the end of the test those checks are reported by KSIG. Here now, all the status were fine, and only 40% of our pizza has more than 6 ingredients. But our test is still as I said. If we want to define our pass-fail criteria, we are going to define thresholds. And the API is a little different. So we are going to define on the option object so many thresholds as we want. And what we are going to be looking are KSIG metrics. We define for every or for the metric that we want, what are the conditions that we expect. In this case, the HTTP rate fail is the HTTP error rate metric. And we tell KSIG that only 1% of the requests should fail. In this one, we are talking about the response times. And we tell KSIG that 95% percentile of the request, 95% of the request should be below half a second. And here, the 99% of the request should be below 1 second. Then we have another threshold based on the custom metric that we defined before. And we tell KSIG the average should be below 2. This one is going to fail. And above if whenever you verify this condition, the condition fails. Let's run this example, and we are going to see how now our test failed. here we are. This threshold was correct, but this one failed because the average was just higher than 2. And KSIG now reports a failure and an informative message. So this is useful, for example, if you want to integrate performance tests on your CI/CD process. And that was all for today's session. But because I know KSIG has much more to offer, I recommend you to visit the KSIG documentation. Read more about the different KSIG features. Try them. Also, there is a section, Testing Guides. Each guide can give you good recommendations about how to approach some type of testing or use case. And if you cannot find in KSIG what you need, go over extensions. There, you can find many extensions from the communities. And there is also a guide to build your own extension for your particular use case. I think that is all for today. Thank you for watching and have happy testing.